question 5. Let's try to understand the diagram first. The question is actually saying that there's a mass of 800 kg bars moving with a certain force forward. So it's trying to move this direction. And there's a resistive force of 2000 newtons. So this is opposite direction. What is the acceleration of the bars? This question I think we have seen it before. The first step, is actually to find the resultant force. You recall what is resultant force is one force that can represent all the forces acting on the object. So in this case, you're trying to move these bars forward. So the resultant force is actually towards the left, and I take the bigger force, which is 3600 minus 2000. So my answer is 1600 newton. So this is the first step. I can find my resultant force. And the second step, try to recall that resultant force is related to the mass F is actually equal to m times a. So in this case, my resultant force I already found that is 1600. So my mass is actually 800, which is my SI unit for mass, times my a. So I can find my a, which is 1600 over 800. So my answer in this case will be 2 meter per second squared. So my answer will be option A. Cool. So if you recall, these are the steps to solve this type of question. First, try to find one single force that will represent all the forces acting on the object, which is 1600. And from recall the formula for F equal ma, and you can find the acceleration. So that is for question 5. What about question 6? Question 6 is actually talking about density, because you are placing object into liquid of different density. So which of the following about density of Q is correct? So you notice Q is actually a liquid. Q is actually not a solid, it's actually a liquid material. So what is the density of Q? So based on your observation, if we put in numbers, it will be much easier. So for example, if I say that S is actually maybe 5, has a density of 5, maybe we give grams per cubic centimeter. So obviously P will be less than 5 because it's less dense. So I can give P as a number, maybe 1 grams per cubic centimeter, because it's less dense. So less dense will always have a smaller density value. So this is denser. This is what you can do to solve this type of question. So 5 is below, 1 is on top. So we can try to fill in the rest. So if R is on top of 5, we can say that maybe R has a density of maybe 3. Because it's less. And Q is still, if it actually R sinks in Q, so we can say that maybe Q has a density of 2 grams per cubic centimeter. So if we now look at we have numbers, it will be much easier to see, right? So it's from 1, 2, 3, 4, and 5. So in this case, density of Q is same. It cannot be the same because the number is different. Higher than the density of R and S. It's not possible because R is 3, S is 5. So the word higher is wrong. So we can cancel out B. It should be less. It's higher than that of P, but lower than that of R. So C is the answer because 2 is more than 1, but it's less than R. So the answer will be C. So that is for this question. What about question 7? Question 7 is actually on the topic of moments. How do I know it's moment? Because of the word pivot. Pivot is actually a fixed turning point. There are many information given. So actually we can resolve this question into a few parts. So it's asking for size of force F. So this is the unknown F. So in order to find this unknown F, we have to apply this concept of principle of moments. What does principle of moments say? Principle of moments says that if I have force, I will have a moment. And if you have a force and a moment, the clockwise moment, every force will have a moment about a fixed turning point. So will be equal to my anti-clockwise moment. So this is the principle of moments. And the pivot must be the same pivot. So in this case, let us try to identify the moments. So if there's a weight acting down, every force will have their own moment. So if acting down and I'm turning about this pivot, if I turn, you notice that the weight will give me actually a clockwise moment. Okay, so it's very important. So the weight will give me a clockwise moment, and in order for it to lift it up, I need to have a opposite direction moment. So it's trying to lift it up, so up about this pivot. So the turning in this case is actually a anti-clockwise moment. Okay, so we have identified my clockwise moment here, and I identified the anti-clockwise moment. So let's try to find the clockwise moment first. So in short form, we use CW. So clockwise moment is actually equal to my force. In this case, my force is actually my weight. How do we find weight of the wheelbarrow? If you notice, they give me the mass. So weight is actually equal to m times g. So it's actually equal to 60 times 10. On Earth, the g is always 10, so it's 600 Newton. It's 600 Newton for my weight. So it's actually 600 Newton force. Thus my perpendicular distance from my weight to my pivot. So actually I take a distance of, actually it's this whole portion. Okay, so it's 70 cm. You don't have to do any conversion because later on in the same unit I can just cancel it out. Okay, so the answer is 42000 Newton cm. So this is for my clockwise moment. Okay, what about my anti-clockwise moment? Okay, so my anti-clockwise moment, I use a short form ACW. My anti-clockwise moment is actually in this direction. So same thing, take my force. My force is unknown, is F. Multiply by my perpendicular distance from my, okay, this one a lot of students always make mistake. Please take note, my perpendicular distance has to be from the line of action of the force to the pivot. So in this case, I have to take this plus this. So my distance I have to take from my line of action of this force to my pivot. So I have to take 70 plus 50, which is 120. This is what a lot of students make mistake here. So in this case, I can equate this to form my principal moments equation. So 120F is actually equal to my 42000. Okay, so my F, we will do cross multiplication. 42000 over 120. So my answer will be 350. Okay, so 350 will be my answer for this question. Okay, let me stop at this page.